Imagine a state of absolute nothingness. No time to tick forward, no light to cast shadows, no dimensions to move through. And then, 13.8 billion years ago, space itself began to stretch. This was the Big Bang, the rapid, explosive expansion of every point in the universe simultaneously. In an instant, the void was replaced by a landscape of unimaginable energy. Given that initial intensity, you might expect the immediate creation of the stars and galaxies we recognize today, but the reality was far more sterile. For millions of years following its birth, the cosmos was entirely pitch black. There were no stars, no suns, and no structures to break the void. The universe had transitioned from a state of blinding, hyper-dense energy into an age of absolute silent darkness. To find the light again, the expanding cosmos first had to undergo a massive physical change. In the first fractions of a second, the universe was a chaotic ocean of pure energy and subatomic particles. The temperature was so extreme that the laws of physics were a tangled, indistinguishable mess, and even the simplest atoms were unable to form. This chart tracks the scale of the early universe against its internal heat. As space expanded horizontally, the overall temperature plummeted. This cooling stabilized fundamental forces, permitting protons and neutrons to bind into the first elements, hydrogen and helium. After 380,000 years of continuous cooling, the expansion reached a point where fast-moving electrons finally slowed down, locking into stable orbits around those atomic nuclei. This stabilization cleared the thick fog of the early universe. For the first time, light could travel across space without being scattered by free particles. This ancient light remains visible today as the cosmic microwave background, the first physical fingerprint of a visible universe. Even with light free to travel, there was nothing to see. The universe entered the cosmic dark ages, a period defined by drifting gas and a complete absence of starlight. Deep within this darkness, gravity began acting as a slow, relentless architect. It exerted a subtle pull on the drifting clouds of primordial hydrogen and helium, drawing them into massive, isolated pockets. For millions of years, gravity pulled these gas networks inward, crushing the center of each cloud until the pressure reached a breaking point. When the heat at the core reached a critical threshold, hydrogen atoms were forced to smash together and merge into helium. This process of nuclear fusion released a massive burst of energy. This single event ended the Dark Ages. The first massive star ignited, transforming the cosmos from a passive expanse into a landscape of active light. These first stars were much larger and more volatile than our sun. They burned at such extreme temperatures that they exhausted their entire fuel supply in just a few million years. This cross-section shows the internal layers of one of those giants. Within its core, the star crushed lighter elements into increasingly heavy ones, forging carbon, oxygen, and silicon until it developed a dense core of iron. Once that iron core formed, the star could no longer produce enough outward energy to counteract its own weight. The internal structure failed, and the star collapsed under the crush of its own gravity. That collapse triggered a supernova, a massive explosion tearing through the void and obliterating the star in seconds. The shockwave of the blast acted as a delivery system, throwing the carbon, oxygen, and iron forged in the core out into the dark, empty voids of space. These scattered heavy elements eventually mixed with surrounding dust and gas, forming the foundational material required to build planetary systems and solid worlds. Over billions of years, these remnants coalesced into the first galaxies, and eventually our own solar system. The iron once trapped in the heart of a dying giant was recycled through the Earth and into the cells of our own bodies, making the modern world the direct physical legacy of those first violent deaths.